Good morning to all. I am Tom Reddy from IT Department, Sri Shanmuga College of Engineering and Technology. And my domain is data structure and algorithms, and I am going to discuss the topic is linked list. So linked list is the topic. First, definition of linked list. What is linked list? That is nothing but linear linked list. It's a linear data structure. DSNet is nothing but data structure in which data is not stored in a contiguous memory location, but each data node is connected to the next node data node via the pointer. List is dynamic size of data structure and it consists of a similar data items. This is the types of linked list. Generally, three types of linked list are present here. One is singly linked list, and next doubly linked list, and third one is circular linked list. So when the item is navigation is forward only, that is in the single list consideration. In the similarly doubly linked consideration, items can be navigated forward and backward. In the circular linked list, the last item contains link of the first element as the next, and the first element has a link to the last element as previous. So this is the representation of linked list. So whenever we choose the first node as a header, that is this is the header, and this is the first node, and this is the next node address, and this is shows the another. Here the synchronous linked list with the 4 nodes. And operation performed on list, that means first creation of node and list and insertion of new element in first middle may be lost, and similarly deletion of required element also in first middle lost, finding an element and traversing and list, these all the enter operation we can perform in the list. And creation of node and list. Here creation of node and list. In this type, in this box we have one data and one is next. Data is the original data, and this next is the next address field. Here the node consists of two fields. In one an element, one is data field and other is next field is the address. So data field contains the actual value and next field holds the address of the next data item. This is the simple code. Here the structure is here struct node, and here we are initialize the data integer as data and struct node. This is for the next hold address. And creation of list. Operation creates a list algorithm. So first, what are the algorithm? By create a list, that means first create a new node. Second, allocate memory. For create a new node using memory allocation. New node is structure node and memory allocation, that is size of the structure node. Read the data for the created node. Created new node and checklist is empty. If empty, assign head and current is equal to new node, and else assign current is as next new node. Current is new node. We can use what are the method, and this is creating a list by inserting a new node. We have inserted new node here. So one new node we have insert here. So that is the node is A node. Okay, and the next address we don't have any next. So that means it automatically represents as a null. So if empty as a head and current, that means it's a new node. Next, this is the head and current node. And next, head and current node is A. We have to insert a B node. Create a list by inserting new node B. That means we have to insert a new node here B. So B is a new node, and next node is next address is we don't have any next address, that is we simply represent as null. So here, and this is current node and this is header, and next this is head. A is head and B is current node. And see here what we done, inserting a new node in a C in existing list. Already one head is A is header and B is current node, and next node is insert the new node is C only. So that means here, and next node is not present here. So that's why the last node is none as null. For pseudocode for list creating. So void create usually and printf enter to create a list and new node as a structure node, and m allocations is memory allocation. We have initialized the memory allocation. So get the new node for scanf, a new node. Next node is null. So if head double equal to null, that means head is equal to new node. Current is equal to also new node. So else current is next is equal to new node. If it's not empty means. So insertion of node in a list, that means algorithm. So first create a node, next allocate a memory for created new node using mallocate. Third, read the data for created new node and enter the position in which new node want to insert. So if first position, that means checklist is empty. If empty, assign, else assign new node is equal to header. Head is equal to new node. So insertion of new element at first position in the empty. So we have only empty list. So and also we have to insert a new element. So that means first let's begin start 1. So one new node is insert. That is D is the new node and this is null. So next address is we don't have. So that was null. So checklist is empty. So if empty is assigned, head is equal to new node. And this is head here. And if the new element, see at the first position in existing list. So D is header, see, and this is we don't have any next, so that is why this is null, and this is C is the first position. So this is new node. So new node is equal to next head and head is equal to new node. Because we are specifying C at the first position. C at the first position means that is automatically allocated as a head. A at the first position means if already C is head means that automatically switch to head. Head position going to switch A because A is the first position. Which note is the first position, automatically it should be act as a head. This is pseudocode for insertion at first position. That means if head is double is equal to null, head is a new node. And else new node is next, that means head. The head is equal to new node. So insertion of new element at the middle position. So here create new node, allocate memory for create new node using mallocate, read data for create new node and enter the position in which new node want to insert. If middle position, that is enter after which data new node want to be insert. Find the position of the data and assign it current node and assign new node next current. So current next is equal to new node. So here insert C after A. That means C insert C after A. That means here we know the first node is as head node, here A, and the last node is here D1 node. If we want to insert the C here, so that means insert here is a C node. So the C node as a new node. This is the code. And printf enter after each data to be inserted, scanf data, get data, and current head. So while current data, if data, current data next. So new node. Okay. Insertion of new elements at last position. Create new node. Allocate memory for created new node. Uh, Using read data for create node, enter the position in which new node want to insert. If last position, find the position of last node in the last and assign it to current pointer. So that is current is equal to next and new node. Insert x at last here. Insert x at last. So this is head, first node, and second node is B, and third node is C. We have to insert at last and a x. So x is a new node. So move the current node next node, that means until current next. This is current is next is new node. So this is X is the last node. And this is pseudocode for at last position, void instruction, last list, current head, and while current next is equal to null and current is equal to next. And current is equal to current next, current is equal to current new node. And this is the insertion at last position of void insertion last list pseudocode. And here we are using one void insertion last list and current is head, while current is greater than head next means that is null. So current is equal to current that is next. Current is next, that means it is a new node. And that's all. Thank you.